tonight. Pluto is no longer the quiet little world at the edge of the solar system. It is something far stranger. Beneath its frozen surface may lie hidden oceans, drifting mountains of solid ice, toxic plains of nitrogen, and a world that refuses to stay dead. For years, it was dismissed as small, distant, and unimportant. But the deeper science looks, the more unsettling Pluto becomes. What was once called a frozen dwarf may actually be one of the most mysterious places ever discovered. Before beginning, a huge thank you to everyone here for spending time with this channel. The support, the curiosity, and the kindness mean more than words can say. If this kind of deep space mystery is fascinating, please like the video, subscribe, and share it with someone who loves science, space, and the unknown. And for those listening right now, it would be lovely to know, what time is it where this is playing, and from which part of the world is it being heard tonight? Now, with that said, let us begin the journey into Pluto and the terrifying truth of what it really is. In the summer of 2006, Pluto does not change in any physical way. It remains where it has always been, travelling on its long, tilted path beyond Neptune, wrapped in cold. Dim light, carrying its frost and rock and hidden weight through the dark. Nothing cracks open, nothing explodes, no surface shifts in response to the debate unfolding on Earth. Yet, on Earth, something abrupt happens to it. A vote is taken. Definitions are tightened. Boundaries are drawn around a word that had once seemed simple. Planet, for generations, has meant a certain class of world, a member of the main family orbiting the Sun. Then the meaning narrows, and Pluto, which had occupied that place in the human imagination since 1930, is pushed aside into a smaller category. It becomes a dwarf planet, a new label that sounds precise in the language of science but feels, to many, like a demotion into irrelevance. The decision grows from a real problem. The outer solar system is no longer empty. By the end of the 20th century and the beginning of the 21st, astronomers are finding more and more icy bodies beyond Neptune, objects in the Kuiper Belt, a vast region of frozen remnants left from the early solar system. Some are small and dim, some are unexpectedly large. One of them, Eris, appears massive enough to force a difficult question. If Pluto is a planet, what happens when more Pluto-sized worlds are found? Either the list of planets grows longer and stranger, or the meaning of the word changes. The International Astronomical Union chooses the second path. A planet must orbit the Sun. It must be round under its own gravity, and it must have cleared its orbital neighbourhood, meaning it dominates its path rather than sharing it with many peers. Pluto meets the first two conditions. It fails the third. It moves among countless icy bodies instead of ruling the region alone. Scientifically, the reasoning is clear enough. Emotionally, it leaves a residue that does not disappear. Pluto has always been an odd member of the old planetary order. Its orbit is eccentric, stretched and slanted compared with the nearly orderly paths of the larger planets. At times it moves closer to the Sun than Neptune, though resonance keeps the two worlds safely apart. It is small, far smaller than Earth's moon, with a diameter of a little over 2,300 kilometers. Even before the new definition, it does not behave like the others. It looks less like a miniature version of the familiar planets, and more like a survivor from a different age, a preserved fragment from the system's construction. But in that very strangeness lies the discomfort. The act of reclassification suggests that oddness makes it lesser. The deeper truth is that oddness may make it important. For decades before the vote, Pluto is more symbol than place. It is a pale dot at the edge of telescopic reach, difficult to resolve, blurred by distance and thin signals. Even the Hubble Space Telescope, powerful as it is, can only offer soft impressions. It reveals bright and dark patches, hints of seasonal changes, signs that methane frost covers parts of the surface. It detects an atmosphere that expands when Pluto draws nearer to the Sun and may partially collapse as it recedes into deeper cold. It confirms that Pluto is not inert in the simple sense people once imagined. But it does not show a world, it shows clues. It shows a puzzle too distant to solve. That uncertainty leaves room for easy assumptions. In the public mind, Pluto becomes a frozen leftover, a dark relic, a minor thing at the boundary of significance. It is often pictured as a static ball of ice, geologically dead, too small to retain heat, too remote to matter except as a terminus, a final marker before interstellar emptiness. Even some scientific expectations are modest. Theories suggest an ancient surface battered by impacts, perhaps layered with volatile ices such as nitrogen and methane that migrate with the seasons. There may be variation, perhaps polar caps, perhaps patches of frost, but there is little expectation of drama. Distance itself encourages understatement. It is easy to believe that the farthest known world must also be the quietest. Yet Pluto resists silence even before anyone sees it clearly. Its atmosphere alone is a complication. It should be fragile, perhaps temporary, because Pluto's gravity is weak and its temperatures are extreme. Nitrogen, methane, and carbon monoxide freeze and sublimate depending on season and sunlight. Observations made during stellar occultations, when Pluto passes in front of distant stars, show that its atmosphere behaves in ways that are not entirely simple. Instead of vanishing cleanly into the cold as expected, it lingers, changes, swells. Surface frosts appear to move from one hemisphere to another across decades. Brightness varies, colour varies. The world seems to breathe, slowly, faintly, but unmistakably. A body that small, that cold, that far away, is not supposed to show such restless exchanges between surface and sky with so much persistence. Then there is Charon, discovered in the late 1970s. Pluto's largest moon changes the picture again. Charon is enormous relative to Pluto, so large that the two bodies orbit a point in space outside Pluto itself. They form a binary pair, less like a planet with a minor satellite and more like two worlds locked together. This alone makes Pluto unusual. It is not merely an isolated object drifting at the edge. It presides over a compact system of its own, a gravitational arrangement unlike any among the classical planets. Later, smaller moons are found as well, adding to the sense that Pluto is not a leftover pebble, but the centre of a complex miniature kingdom. The more carefully astronomers observe from afar, the less comfortable the old caricature becomes. Pluto is small. Yes, it is cold beyond ordinary experience. Sunlight at that distance is so weak that noon would resemble a strange twilight if there were an observer standing there. But cold is not the same as simplicity. Ice is not the same as stillness. In the outer solar system, materials behave differently. Nitrogen can become bedrock. Methane can frost the ground like seasonal weather. Water ice, under such low temperatures, hardens into something more like stone. Chemistry that seems exotic on Earth becomes the architecture of entire landscapes. A place once dismissed as a frozen cinder begins to look more like a laboratory, where the solar system hides some of its least intuitive rules. This is the part that gives the reclassification its strange aftertaste. Pluto is removed from the old list not because it is too simple to belong, but because it belongs to a different population whose meaning is only beginning to emerge. The Kuiper Belt is not empty rubble. It is a frontier of preserved worlds, bodies that have spent billions of years in dim cold, holding records of formation, migration, and chemical history. Pluto may be the most accessible of them only because it was found first and named early. It stands at the threshold between the known planets and a wider architecture that the 20th century barely glimpsed. To demote it is, in one sense, accurate taxonomy. In another sense, it is an admission that the old map of the solar system has failed. By the time the vote is over, the public argument settles faster than the scientific one. Textbooks change, schoolroom models are revised, Pluto's new status turns into a cultural shorthand for exclusion. But among planetary scientists, the real story is not ending. It is about to begin. A spacecraft is already on its way, launched earlier that same year, before the debate reaches its final symbolic break. New Horizons is racing outward faster than any mission sent toward the outer planets before it. It carries cameras, spectrometers, particle detectors, and a simple promise. It will not define Pluto by committee. It will look. That promise matters because Pluto has become trapped between language and ignorance. The argument on Earth has hardened around a classification while the world itself remains mostly unseen. The object at the centre of the debate is still only a suggestion in telescopes, still a blur of reflected sunlight and inferred chemistry. It has been judged before it has been properly witnessed, and there is something unsettling in that order of events. A category has closed around a place that nobody has yet visited, around a terrain nobody has mapped, around an atmosphere no one has flown through, around an interior no one understands. Pluto, in this moment, seems less like a fallen planet than a sealed file. It has been labelled and shelved while still full of unknowns. Out beyond Neptune, none of this matters to Pluto itself. It continues through the dark with Charon beside it, carrying frozen nitrogen, methane, carbon monoxide, rock, water ice, and whatever lies deeper below. It reflects a weak, reddish light. It turns slowly. Seasons crawl over its face with almost unimaginable patience. The smallest motions take years. The deepest changes may take ages. And yet the impression it gives from afar is no longer one of emptiness. It is the impression of distance used as camouflage. A world that seems too remote to surprise may simply have had more time to hide. New Horizons leaves Earth before Pluto's new status settles fully into culture. It launches in January of 2006 on a pillar of flame and urgency, rising not toward a nearby target but towards something that will remain almost imaginary for most of its voyage. The mission is built around a strange problem. Pluto is known, named, tracked, measured in broad terms, and yet almost nothing about it is directly seen. It exists in data, in changing light curves, in carefully interpreted shadows during occultations, in a handful of blurry maps. It occupies the edge of knowledge in a very literal way. To reach it requires patience on a scale that strips away ordinary expectations, not the patience of waiting for an answer in weeks or months, but the patience of sending a machine into a region where the signal from home will weaken year after year, and where even a successful encounter will happen only once, at enormous speed, with no chance to brake, circle back, or correct after the fact. New Horizons is not going to Pluto in the way a surveyor walks through a landscape. It is diving through it, crossing the outer solar system on a time trajectory that allows no hesitation, even at speeds that seem almost excessive by human standards. The voyage takes more than 9 years. That alone begins to change the feeling of the destination. Any place that requires nearly a decade to reach, even by one of the fastest machines ever sent from Earth, starts to feel less like a member of the local family and more like a withheld domain. The mission cuts across the inner system, passes the orbit of Mars, moves beyond the asteroid belt, and heads toward Jupiter for a gravity assist. That encounter in early 2007 is not the mission's main prize, but it is useful in more than one way. Jupiter lends speed, bending New Horizons outward and helping it shave years from the journey. It also gives the spacecraft a rehearsal. Instruments are tested on a real planetary system. Cameras sharpen their practice on clouds, rings, and moons. The mission team learns how the spacecraft behaves under pressure and distance. Then Jupiter falls behind, and the true emptiness begins. Between Jupiter and Pluto there is distance on a scale that resists intuition. The resist intuition. The spacecraft moves through a region where even giant planets are absent, and the sun becomes less a source of warmth than a bright reference point. Communication delays lengthen. Commands cannot be improvised in a hurry. Every major action must be planned in advance, transmitted, received, and carried out with trust that the craft, alone in the dark, will do what it has been told. The machine spends long stretches in hibernation to preserve systems and reduce risk. During those periods it is not dead, only quiet, checking itself, keeping time, crossing the void with a kind of disciplined sleep. This aspect of the mission deepens the unease around Pluto in a subtle way. The world ahead is not merely far. It is far enough that approach itself becomes a technical and emotional event. The target is so distant that New Horizons spends years moving toward a place that never seems to grow in the sky. Pluto remains point-like, then barely more than point-like, then a slowly thickening presence in the data. The outer solar system has a talent for making enormous things look trivial, simply because light is sparse and distances are absurd. The mission team knows the numbers. They know Pluto is a genuine world, one with a measurable atmosphere, a major moon, and seasonal changes. Yet the visual reality arrives painfully slowly. There is no dramatic swelling disk on the horizon for most of the trip. There is a slow correction of perspective, a steady refusal of the universe to reveal scale without prolonged effort. This changes the tone of the investigation. The closer New Horizons gets, the more important time becomes. Because the spacecraft will race past Pluto at such high speed, every observation must be sequenced with near-exact precision. Cameras will not linger. Spectrometers will not wait for second thoughts. The encounter window is narrow, and the amount of data that can be gathered depends on preloaded choreography executed across many hours as the craft hurtles through the system. There is something almost paradoxical here. A 9-year journey is aimed at a visit that unfolds in a burst. The mission drifts across interplanetary darkness for nearly a decade, and then confronts Pluto in a rapid, irreversible crossing. That contrast gives the destination a peculiar tension. A world hidden so long will present itself all at once, and whatever it reveals must be accepted on the move. Meanwhile, the scientific expectations continue to evolve. Before New Horizons arrives, astronomers already know that Pluto is not a uniform sphere. Surface maps made from decades of brightness changes suggest contrasting regions, some brighter, some darker, likely reflecting mixtures of nitrogen, methane, and older, darker material processed by radiation. There is evidence of frosts moving with the seasons. There are indications that the atmosphere changes pressure as Pluto recedes from the Sun after its late 20th century perihelion. The point in its orbit nearest the Sun, there is still debate about how rapidly the atmosphere should collapse as the surface cools. Some models predict a dramatic thinning. Observations do not fully cooperate. Pluto seems able to hold on to complexity longer than expected. The atmosphere, however thin, becomes an especially haunting detail during these years. On Earth, atmosphere is associated with weather, sky, movement, circulation. On a body so small and cold, far beyond the warm domain of the terrestrial planets, its presence feels almost illicit. Pluto should be nearly stripped bare by cold. Instead, it has a shroud, transient perhaps, but real. Nitrogen gas rises from frozen plains when sunlight is sufficient, then resettles elsewhere. Methane lingers. Haze may form high above the ground, even before arrival. Pluto is behaving less like a dead object and more like a world with cycles. That is the crucial difference. Dead objects accumulate change only from outside, from impacts and radiation and slow decay. Worlds with cycles rearrange themselves from within and across their surfaces. Pluto is already suspected of doing that. The mystery lies in how much and why. Karen grows in importance as the encounter approaches, because the two bodies are tidally locked, each always showing the same face to the other. They form a stable duet. Pluto and Karen revolve around a shared centre of mass in a cosmic pattern more balanced than any planet and moon pair known among the major worlds. This binary character implies an unusual origin, likely a massive ancient collision, though the exact details remain uncertain. It also means that Pluto cannot be understood alone. Its largest moon may preserve part of the same history in a different form, colder in some ways, stripped in others, marked by transferred material from Pluto itself. The system is beginning to feel less like a distant planet with attendants and more like a complete environment, a self-contained outer kingdom whose members interact in slow, persistent ways. As the years pass, the mission itself acquires a strange symbolic weight. New Horizons is heading not only toward a target but toward a correction. Pluto has spent decades beneath interpretation. Everything known about it has been mediated through distance. Each model carries assumptions inherited from more familiar planets or moons. A flyby will not solve everything, but it will confront those assumptions with actual terrain. There is a quiet risk in that. For all the suspense around discovery, there is always the possibility that the world will be simpler than hoped. It might reveal an old cratered shell, a thin skin of frost, a little atmosphere, and not much else. That possibility is scientifically valuable, yet emotionally deflating. The long investment of time and imagination might end with confirmation of barrenness. But the outer solar system has a history of humiliating modest expectations. Voyager found active volcanoes on Io where none were expected, fractured oceans under ice on Europa, young terrains on Triton, geysers and atmospheric complexity in places once assumed inert. One by one, the distant worlds had refused to be boring. Pluto, though smaller, now waits in that same tradition of possible embarrassment for human certainty. By 2015, the point of light ahead is no longer just a point. Pluto and Charon begin to separate in approach images. The system starts to show shape. Additional moons are known: Nix, Hydra, Kerberos, Styx, small, irregular, dim, and difficult. They complicate navigation because dust or debris could threaten the spacecraft at flyby speed. Hazard searches become intense. Alternate trajectories are considered. A grain of unseen material at those velocities could destroy the mission. Even the space around Pluto hints at tension. The approach is not only wondrous, it is dangerous. The spacecraft enters its final programmed sequence and becomes, in effect, committed. There is no human hand guiding it in real time. Radio signals take hours to cross the Gulf. The encounter will happen largely before Earth knows, and the spacecraft will have to survive it on its own. This, too, changes how Pluto is perceived. The world at the edge is not merely being observed, it is being trusted with a machine carrying years of work and expectation, and it will disclose itself on its own terms. Then, at last, the first resolved images begin to arrive. The disk is no longer an inference. It has contrast, bright regions, dark regions, a surface that looks arranged rather than random. One bright feature becomes immediately impossible to ignore. It stretches across Pluto's face with a form so clean and so emotionally legible that the human mind reacts before science can. It looks like a heart. That is the instant when Pluto changes again, not by vote and not by category, but by visibility. The old exile of the solar system has stopped being an argument and become a place, and the first clear sign it offers is not a cratered ruin or a blank ball of ice, but a shape so improbable, so stark, and so charged with meaning that it feels almost like a trap. The closer the images come, the less innocent that bright heart appears. The first close view of Pluto does not arrive as a complete revelation. It emerges piece by piece, image by image, each transmission sharpening the sense that this world has been misjudged for most of modern astronomy. Long before the highest resolution frames reach Earth, one feature dominates the growing disk. It is broad, pale, and startlingly symmetrical at a glance, spread across a large portion of the hemisphere facing the spacecraft during approach. It looks uncannily deliberate, as though the surface has arranged itself into a sign that human eyes cannot help but recognize. The public sees a heart. Scientists see contrast, albedo, boundaries, topography still unresolved. Yet even within that more cautious reading, the impression is impossible to dismiss. Pluto is not presenting a monotonous shell of frost and impact scars. It is showing internal organization, large-scale pattern, a geography with regions that seem to belong to different histories. The bright heart is later divided into two distinct lobes. The western lobe is smoother, brighter, and more regular. The eastern lobe is rougher, more mottled, and less uniform. Together they form Tombor Regio, named for Clyde Tombaugh, the astronomer who discovered Pluto in 1930. But it is the western lobe that becomes the centre of unease. This is Sputnik Planitia, a vast basin filled with volatile ice, mostly nitrogen, with carbon monoxide and methane mixed in. It is not a static deposit. It is not a frozen pond lying untouched beneath weak sunlight. Almost immediately, its surface tells a more disturbing story. It is remarkably young. It is almost devoid of impact craters. On a world exposed to the solar system for billions of years, that absence matters. Craters are clocks. They accumulate where surfaces remain unchanged. Where craters are missing, something has been active enough to erase them. This is the first deep break with the old picture of Pluto as a dead relic. The bright heart is not ancient in the simple sense. It has been resurfaced. It has been renewed. Something on Pluto has been moving recently enough, in geological terms, to wipe clean an enormous region at the edge of the solar system. The surface of Sputnik Planitia resolves into vast cellular patterns, broad polygons separated by shallow troughs. They look from orbit like the skin of something slowly stirring below. The simplest explanation is solid-state convection. The nitrogen ice is so deep, and Pluto's internal heat, though weak, is so persistent, that the ice may slowly overturn. Warmer material rises from below. Colder material sinks. The process is extremely slow by human standards, perhaps on timescales of hundreds of thousands of years, but on a planetary surface it is dramatic. It means the plane is not merely sitting there, it is circulating. A frozen basin is behaving like a sluggish fluid. This is the moment when the heart ceases to feel benign. Its brightness, its clean outlines, even its smoothness begin to imply not peace but motion concealed under stillness. On Earth, smoothness often means rest. On Pluto, smoothness is evidence that the landscape has not been allowed to age. It has been renewed from within. The scale of the basin is immense, roughly 1,000 kilometers across, large enough to dominate an entire hemisphere. Its position is peculiar as well. It lies near the hemisphere that faces Charon, and its mass distribution appears to matter for Pluto's orientation. Some researchers think the basin may have helped reorient the entire dwarf planet through a process called true polar wander, in which a world shifts so that a heavy region settles into a more stable position relative to its axis. That possibility deepens the strangeness. The bright plane may not merely be a surface feature, it may have altered the posture of the world itself. Yet the mass puzzle is not simple. A basin should represent missing material, a deficit, something lighter than the surrounding crust. Sputnik Planitia instead seems associated with positive mass, as if something dense below is helping hold it in place. That is one of the reasons the buried ocean hypothesis gains strength. If a subsurface ocean exists beneath Pluto's ice shell, then the impact that formed the basin may have thinned the crust, allowing denser liquid water below to create a gravitational anomaly. In plain terms, the heart may remain where it is because something heavy and hidden lies under it. Thus, the visual center of Pluto's face points downward, toward a possible unseen sea. But the mystery begins at the surface. New Horizons sees no obvious large craters in much of Sputnik Planitia. It sees flow patterns around the margins. It sees pits and textures that suggest sublimation, where ice turns directly into gas. It sees the edges of the basin crowded by mountains that appear jumbled, displaced, and in some cases stranded like fragments carried and set down by moving ice. The basin looks less like a static depression and more like a machine operating in slow time. Nitrogen on Pluto is not a minor frost sprinkled over rock. It is a major geological substance, a working material that can gather in deep deposits, deform under weight, creep under small gradients, and move across landscapes. It is difficult to overstate how alien this is. On Earth, nitrogen is something breathed from the air and barely noticed. On Pluto, it can become a glacier hundreds of meters deep, perhaps deeper, circulating under a black sky. The eastern half of the heart complicates the picture further. This terrain is brighter than much of Pluto, but it is more rugged, cut by ridges and slopes, less serene than Sputnik Planitia. It appears older in places, more complex, part frostfield and part elevated terrain. Together, the two lobes create the illusion of a single symbol, yet geologically they are not the same story. This matters because it breaks the temptation to read intention into the shape. Pluto is not drawing a sign. It is collaging unrelated histories into a form that happens to look familiar from a certain angle. That accidental familiarity makes the world more unsettling, not less. Human pattern recognition latches onto the heart and softens the reaction. But the actual reality is colder. One lobe is an active nitrogen basin that appears to consume impacts and slowly overturn itself. The other is older, rougher terrain with its own record of frosts and tectonic strain. Beauty here is an optical accident laid over very unearthly processes. The encounter data also show that the heart is not isolated from the rest of Pluto's climate. Nitrogen ice is volatile under Pluto's conditions. It can sublimate in one place, enter the atmosphere, drift, and refreeze in another. Sputnik Planitia seems to function as a cold trap, a place where these ices can gather and persist. Because the basin lies low, because its surface is bright and reflective, and because the ice there may be thick, it becomes a climatic engine. In some seasons it may feed the atmosphere, in others it may draw gases back down. This raises an eerie possibility. The Great Bright Plain may be one of the structures that allows Pluto to maintain a fragile atmosphere at all. The heart is not merely a passive surface, it may be part of the breathing mechanism of the world. Even the colour of Pluto contributes to the shift in tone. From afar it had often been imagined as grey or vaguely brown, a dim body at the threshold of darkness. Up close it shows subtle reds, browns, creams, and pale blue hazes in the atmosphere. The heart stands out because it is lighter than its surroundings, but around it darker terrains spread like weathered stains. Cthulhu Macula, the great dark equatorial belt, extends across a huge region with a reddish-brown cast, likely rich in tholins, complex organic residues formed when sunlight and charged particles alter methane and nitrogen. This juxtaposition is arresting. At the centre lies a pale basin of mobile nitrogen. Around it lie older, darker terrains chemically processed into deeper tones. Pluto looks less like a frozen pebble and more like an archive of incompatible states held side by side, fresh and ancient, bright and dark, mobile and rigid, simple molecules transformed into elaborate surface chemistry. No single description contains it for long. The more closely the heart is studied, the less it resembles a reassuring emblem and the more it behaves like a controlled anomaly. Why here? Why so young? Why so free of craters? Why so massive in implication? Why does a world this small still preserve enough internal heat to drive motion in such volatile ices? Why does a body so remote maintain a climatic cycle intricate enough to collect, redistribute, and perhaps replenish these materials? The known answers are partial. Pluto likely formed with rock and ice mixed together. Radioactive elements within its rocky portion release heat very slowly over immense timescales. That heat may be enough to keep some deeper layers warmer than the surface suggests. The surface ices respond to sunlight and season, but their large-scale behavior depends on topography, albedo, pressure, and internal structure. Nothing here violates physics. That is what makes it more impressive. Pluto is not impossible. It is simply arranged in a way that exposes how incomplete ordinary intuition can be. There is another subtle consequence of the heart's youth. If Sputnik Planitia has been active recently, and perhaps still is, then Pluto's present era is not an exhausted aftermath. This is not a world being viewed long after all meaningful events have finished. It is a world caught in the middle of processes that continue now, in darkness, in cold so severe that water becomes bedrock and nitrogen becomes moving land. The idea is hard to absorb because motion on Pluto is not dramatic in the human sense. There are no visible rivers in the usual meaning, no waves, no trees bending in wind, no rolling weather fronts like those on Earth. The activity is patient. It unfolds in slow cellular overturn, in glacial creep, in seasonal transport of frost, in atmosphere that grows and shrinks, in a surface that quietly deletes its own scars. Yet that patience may be more unsettling than violence. Violent worlds reveal their energy openly. Pluto hides its activity in a calm face. The heart is the best example of that concealment. It appears soft, bright, almost gentle. Underneath, the evidence suggests weight, motion, and buried complexity. The eye sees a symbol. The measurements see a basin that should not be as alive as it seems. And beneath both lies the growing suspicion that Pluto's central mystery is not written on its surface at all, but under the bright plain, below the ice, where the heart points towards something unseen and heavy in the dark. Sputnik Planitia looks calm from a distance, but nearly everything known about it suggests that calm is an illusion created by scale. The plain is broad, pale, and almost serene in the first global views, a clean expanse set inside the brighter half of Pluto's heart. It does not carry the crowded scars expected on an ancient surface. It does not resemble the dark belts elsewhere on Pluto, where age seems written openly into colour and texture. Instead, it presents a strange kind of freshness, as though a vast portion of the world has been resurfaced so recently that time has not yet had the chance to mark it properly. That freshness is one of the most unsettling facts New Horizons finds, because it cannot be dismissed as a visual trick. In the outer solar system, impacts happen over immense spans of time, and old landscapes preserve them. Where there are no craters, the surface has not simply remained fortunate. It has been changed. Something has covered, erased, buried, or reworked the damage. On Pluto, that conclusion lands with special force. This is a small body, far from the sun, with no large source of tidal flexing like that experienced by moons close to giant planets. It should not be energetically extravagant. Yet here is a basin so young in appearance that it forces the admission that Pluto has not gone still. The simplest estimate places much of Sputnik Planitia at an age of no more than a few tens of millions of years, perhaps even younger in places. Against the age of the solar system, that is startlingly recent. It means the bright plane is not a fossil from the beginning. It is an event that continues. The geometry of the plane deepens the impression of ongoing motion. Across much of its surface stretch broad cellular patterns, large polygonal shapes outlined by shallow troughs. They do not look like impact features. They look organized, repeated, and internal, like the visible skin of a process below. Planetary scientists compare them to convection cells. On Earth, convection appears in boiling water, in the mantle over vast scales, in atmospheric circulation, in any layered material where warmer and cooler portions exchange position under gravity. On Pluto, the idea seems almost absurd at first because the material in question is solid nitrogen ice. But under Pluto's conditions, even solids can flow slowly if they are thick enough and soft enough over time. Nitrogen ice at Pluto's surface temperatures is much weaker than water ice. It can deform, creep, and overturn if internal warmth, however slight, leaks upward from below. That means Sputnik Planitia may work like a frozen sea that rises and sinks in increments too slow for any eye to witness directly, yet fast enough to refresh the surface over geological time. Each polygon may mark a convective cell where ice wells up near the centre and gradually sinks at the boundaries. The entire plane may be circulating in silence. That possibility changes the meaning of the missing craters. An impactor striking a stable frozen crust would leave a scar. Perhaps softened over ages, but still there. An impactor striking a circulating reservoir of nitrogen ice enters a different world. The crater may form, then slowly relax. It may be infilled by moving ice. It may sink as the surface overturns. It may be erased until only the newest or most unusual impacts survive. In the sample of New Horizons imagery, few do. The basin behaves as though it is eating its own history. Every scar that should have helped decode the chronology disappears into motion. The plane does not merely resist damage, it digests it. That is why the metaphor of a toxic sea, though dramatic, carries some truth. Sputnik Planitia is not liquid in the everyday sense, but it functions like an active reservoir. It receives material, reworks it, and conceals the record. In that sense, it swallows impacts as effectively as any ocean. The margins of the basin reinforce this impression. There the smooth nitrogen plains meet broken uplands, mountain blocks, ridges, scarps, and disturbed terrain that appear as though the basin has interacted with older crust and altered it. Some blocks of water ice seem detached from surrounding mountains and stranded within the plain, like icebergs frozen into a different kind of sea. Because water ice at Pluto's temperatures is extremely hard, it behaves as the bedrock of this world, while nitrogen becomes the mobile substance. This inversion is one of Pluto's deepest disorientations. On Earth, water shapes the mobile surface and rock anchors the land. On Pluto, water is the strong framework and nitrogen is the wandering skin. That reversal allows pieces of the older crust to appear as floating or drifting masses in the basin, carried or repositioned by the movement of the softer surrounding ice. Some mountainous fragments at the edges of Sputnik Planitia seem exactly like that. Rafts of rigid water ice isolated within a broader field of slowly moving nitrogen. The basin is not only renewing itself, it is reorganizing the terrain around it. There are also pits, shallow depressions, and textured zones that suggest sublimation, the direct transition of ice into gas. On Pluto, this is not a minor process. The atmosphere is thin but dynamic enough to participate in exchanges with the surface. Sunlight, even weak at that distance, can still drive seasonal transport. Nitrogen and methane freeze out and then re-enter the atmosphere under changing conditions. Sputnik Planitia, being low and bright and packed with volatile ice, likely serves as one of the main reservoirs for this exchange. It may gather the planet's mobile ices and then feed them back into the atmosphere when seasons and local temperatures permit. In this way, the basin is not only geologically active, it is climatically central. Pluto's fragile atmosphere may depend in part on the heart basin's ability to store, release, and redistribute the very gases that become its air. This gives the plane a double character. It is a landscape and a system. It is a place that can be mapped, but it is also a process that never fully settles into one form. Even the term glacier, though accurate in one respect, is almost too static for what is happening. On Earth, glaciers flow, crack, erode, and transport debris, but they usually move over a more stable substrate. Sputnik Planitia may be both glacier and substrate at once, a deep deposit whose own interior circulates while its surface migrates, and its margins reshape neighbouring terrain. It is an engine made of ice that should barely be able to exist under conventional expectations, yet clearly does. The source of the motion remains one of the most important questions. Pluto is small. It should have lost much of its internal heat long ago. Yet complete loss is not required. Only a faint flow from radioactive elements in the rocky interior may be enough, if the overlying nitrogen is deep and deformable. Tiny gradients sustained over millions of years can do extraordinary work in planetary settings. What matters is not heat in the human sense of warmth, but heat relative to the brittleness of the material above. Nitrogen does not need much encouragement to move when spread across a basin of this scale. The same weak internal energy that would seem trivial on Earth may be transformative in a frozen environment where the surface rests close to the thresholds between rigidity, creep, and sublimation. Then there is the basin's origin. Many researchers interpret Sputnik Planitia as a giant impact structure later filled with volatile ice. The basin's elongated shape and depth support that idea. If so, then a massive collision once struck Pluto hard enough to excavate part of its crust. But the impact alone does not explain the present. An ancient crater could simply have remained an old scar. Instead, it became a gathering place for nitrogen, a cold trap, a centre of resurfacing, perhaps even a factor in the reorientation of the whole dwarf planet. What began as destruction may have turned into a planetary organ. This conversion is itself part of the mystery. Pluto seems able to turn damage into function. The wound becomes the heart. The excavation becomes the basin that regulates climate, stores volatile ices, renews the surface, and possibly points to deeper liquid water below. The ocean idea returns here because the basin's behaviour is difficult to separate from Pluto's interior. Models of Sputnik. Planitia's present position suggests that a positive mass anomaly beneath it helps hold it where it is. One way to generate that anomaly is through uplift or thinning above a deeper layer of liquid water, denser than the surrounding ice shell. If that interpretation is right, then the moving nitrogen plane is only the visible cap of a much larger secret, a buried ocean, insulated by the ice above, and perhaps still partly liquid after billions of years, may sit under Pluto's brightest and youngest terrain. The basin would then be an interface between three realms at once atmosphere above, convecting volatile ice at the surface and hidden water below. The apparent simplicity of a smooth plain would conceal a vertical stack of interacting systems. This is where observation begins to widen into speculation without leaving solid ground. The known facts are enough to make Pluto uncanny. A young surface exists where an old one should dominate. Solid nitrogen moves on a world once assumed inert. Mountains of water ice appear to float in a basin that renews itself. The atmosphere may depend on this reservoir. The orientation of Pluto may reflect its hidden mass. Beneath it all may lie water that has avoided freezing for unimaginable spans of time. None of this proves anything exotic beyond geology and climate. Yet it changes the emotional texture of the world. A dead object becomes a layered mechanism. A bright plain becomes a place that swallows evidence, masks age, and draws attention downward. It is not that Sputnik Planitia looks threatening in a theatrical sense. It is that it is too active in too many ways for a world this small and remote. It keeps behaving like the visible top of something larger than itself, as though Pluto's most important processes are not on the surface at all, but hidden in the slow exchanges between frost, ice, gravity, and whatever still endures below the crust. At the edges of Sputnik Planitia, Pluto reveals one of its most complete inversions of common sense. The bright basin itself is already difficult to accept as a moving field of nitrogen ice, but the terrain surrounding it makes the deeper lesson unavoidable. Here rise mountain ranges and isolated blocks that look, at first glance, like the sort of hard, permanent foundation on which an ordinary frozen plain might rest. Yet on Pluto, the ordinary order of materials has collapsed. The strong substance is not rock in the familiar planetary sense. The strong substance is water ice. In the severe cold of Pluto's surface, water freezes into something so rigid that it behaves like stone, while nitrogen, methane, and carbon monoxide remain comparatively soft and mobile. This turns the world inside out. The material associated on Earth with glaciers, snowfields, and rivers becomes the equivalent of bedrock. The materials associated on Earth with air and trace frost become the flowing landscape. Once that reversal is understood, the mountains around the basin stop being scenery and become evidence. They are the hard pieces left standing while the softer world moves around them. New Horizons sees these mountains in astonishing forms. Some stand in jagged chains near the rim of Sputnik Planitia, rising several kilometers above the neighboring plain. Their slopes are steep, their profiles are rough, angular, blocky, not worn down into the rounded calm expected from long weathering. They appear young, or at least freshly exposed, uplifted or fractured on a timescale that preserves sharp relief. Among the most striking are the ranges informally compared to terrestrial mountains, not because they are geologically identical, but because they impose the same sense of abrupt scale. Hilary Montes and Tenzing Montes, named later in honour of explorers of another frontier, rise like frozen walls along the margin of the nitrogen basin. Their existence alone is remarkable. On a small body with weak gravity, high topography is easier to support than on Earth, but only if the material is strong enough. Water ice under Pluto's conditions is exactly that strong. These mountains stand not in spite of the cold, but because of it. The temperature that should have reduced Pluto to passive frost instead gives it architectural hardness. Some of these mountainous masses appear less like rooted ranges and more like detached fragments. They sit within or near the edge of the basin as though broken loose from older crust and displaced. This is where the image of floating mountains becomes more than poetic. Because water ice is less dense than solid nitrogen, enormous blocks of Pluto's water ice crust can, in principle, float within deep nitrogen deposits the way ordinary icebergs float in water. That does not mean they bob visibly or drift quickly in any human sense. Movement on Pluto is patient almost beyond imagination. But over geological spans, if the nitrogen ice is deep enough and mobile enough, large blocks may be carried, rotated, stranded, or crowded together. The basin margins preserve signs of exactly this kind of interaction. Some mountain clusters seem chaotic, as though they have been transported and jammed. Some isolated blocks rise from the plain like rafts trapped in a frozen current. The idea is difficult because the objects involved are mountainous in scale. Yet Pluto's physics keeps insisting on it. Things that should seem immovable may not be fixed at all. The ground near the basin may be only conditionally ground. That possibility gives Sputnik Planitia an even stranger character than a convecting plane alone would suggest. It is not merely resurfacing itself, it may also be rearranging fragments of the surrounding crust. The mountains do not sit beside a passive basin, they interact with it. In some regions, the nitrogen plane appears to flow around obstacles, pooling, thinning, or curving along their edges. In others, the mountains look partly engulfed, as though an older crust has been invaded by volatile ice that fills the low places and leaves the harder blocks exposed like island chains in a pale sea. The language of coastlines, islands, and icebergs begins to appear naturally, even though almost nothing here behaves as it does on Earth. Pluto encourages analogy, then quietly breaks it. There are no liquid seas under the black sky, yet the landscape suggests marine logic. There are no wave-cut shores, yet there are margins that look invaded. There is no water moving on the surface in the earthly sense, yet there are masses that appear to float. It is a geography assembled from familiar shapes and alien materials. The mountains also sharpen the contrast between old Pluto and new Pluto. Before the flyby, many expectations for the dwarf planet lean toward a heavily cratered, geologically simple surface interrupted mainly by seasonal frosts. The ranges around Sputnik Planitia do not fit that picture. Their scale and freshness imply tectonic strength. Crustal fracture, uplift, or emplacement processes that remain incompletely understood. Some may be the broken remnants of the basin-forming impact. Others may reflect broader stresses in Pluto's crust, driven by internal change, freezing or expansion of deeper layers, or shifts in the distribution of surface loads as volatile ices migrate. The details vary from region to region, but the message is consistent. Pluto's outer shell has not sat unchanged for billions of years. It has cracked, shifted, and built relief. A world once treated as a quiet endpoint turns out to preserve signs of force. This force is visible not only in the great ranges, but in the many smaller textures that cover the boundary zones. Some slopes are streaked with brighter deposits. Some valleys seem filled or partly buried by nitrogen ice spilling out from the basin. Some plateaus stand apart with sheer edges that suggest collapse or separation. There are places where the surface looks gnawed, where sublimation may be sculpting pits and roughened facets into exposed water ice. There are places where mantles of volatile frost smooth what must once have been harsher terrain. The result is not uniform. Pluto's mountains are not a single story repeated many times. They are fragments of a more complex conversation between structural strength and climatic erosion, between the deep rigidity of water ice and the migratory habits of more volatile materials. Every major scene at the basin margin seems to record a different balance between permanence and movement. The red material that lightly dusts parts of Pluto complicates the mountains further. Higher elevations in some regions appear capped or coated by darker reddish deposits, probably tholins formed when sunlight and charged particles alter methane into more complex organic residues. Over immense spans of time, this material settles out of the atmosphere or forms where methane frost is exposed and processed. On Earth, mountain snow often appears bright because of fresh accumulation. On Pluto, peaks can wear a darker, redder mantle. Depending on chemistry, season, and local temperature. This is one of the most visually unsettling facts about the planet. The summits do not simply gleam white in distant light. In some places they darken, as though the sky itself has been slowly staining them. The image has a quiet violence to it. A mountain already made of ice hard as stone then acquires a coating of organic residue under a sky that is too thin to be comforting and too active to be ignored. Even the concept of erosion becomes unfamiliar here. On Earth, wind, rain, rivers, glaciers, and temperature cycles wear mountains down with relentless variety. Pluto lacks rain in any ordinary sense. It lacks liquid rivers on the surface. Its winds are likely gentle compared with those of larger atmospheres. Yet its landscapes are not immune to change. Sublimation can carve exposed ices. Deposition can bury relief. Creep in surrounding nitrogen can undermine blocks and shift margins. Thermal cycles across Pluto's long seasons can redistribute frosts over years and decades. A mountain on Pluto may not be attacked by rainfall, but it may still be modified by the slow breathing of the atmosphere and the wandering of volatile ices around its base. Time operates differently, but it still works. The physical strength of water ice on Pluto also points toward the world's hidden interior. If mountains of this size can stand, then the crust is not only cold but substantial. It must preserve a rigid outer shell capable of bearing stress. Yet that shell cannot be the whole story, because the basin beside it behaves as though something softer and more dynamic lies nearby, and the orientation of Pluto suggests deep compensation at larger scales. The mountains therefore become part of the evidence for layering. There is an outer crust strong enough to fracture and stand high. There are volatile deposits soft enough to flow and convect. There may be deeper zones where water ice changes state, temperature rises, and perhaps liquid remains trapped beneath pressure. Pluto's mountains are not just topography. They are the exposed edges of a layered world whose material logic changes with depth. There is another reason these mountains matter. They restore scale to a place that distance had once flattened. Before New Horizons, Pluto's small diameter tempted the mind to miniaturize everything about it. Small planet, small drama, small terrain. But a world does not need great size to produce grandeur if its materials and temperatures allow vertical relief. On the margins of Sputnik Planitia, Pluto proves that compact worlds can still be monumental. Towers of water ice rise under a black sky lit by a sun that has shrunk to a fierce point. Broad plains of nitrogen spread away from their bases. Charon hangs elsewhere over the horizon of the locked hemisphere, fixed in place. The setting does not need motion to feel alive. The materials themselves are already wrong enough by Earth standards to create unease. A mountain made of the same substance as terrestrial glaciers ought to suggest fragility. On Pluto, it suggests endurance. A basin made of the same nitrogen that fills Earth's air ought to suggest emptiness. On Pluto, it suggests depth. This reversal lies at the center of Pluto's power over the imagination. It does not merely present new objects, it rearranges the hierarchy of matter. It teaches that under different sunlight, different pressure, and different temperature, the categories that shape everyday intuition lose authority. Soft becomes hard, gas becomes terrain, frost becomes geology. A world dismissed as marginal becomes one of the clearest demonstrations that planetary reality is wider than the habits of Earth allow. The mountains around Sputnik Planitia stand as the most immediate monuments to that fact. They refuse to sink because the surrounding plain is softer than they are. They may drift because the basin is deeper and more active than it looks. They remain sharp because cold here preserves strength, rather than merely extinguishing life. And beyond their jagged lines, under the thin haze and the dim sun, Pluto continues to hold its shape while quietly overturning almost every simple expectation brought to it from the inner solar system. Above Pluto's mountains and plains, there is almost no sky by earthly standards. The air is thin, the pressure at the surface tiny compared with anything comfortable or familiar, and the sunlight that reaches this distant world is weak enough that noon would still feel like a kind of permanent dusk. Yet New Horizons reveals that Pluto does have an atmosphere, and once it is seen clearly, the old idea of Pluto as a bare frozen remnant becomes even harder to defend. The atmosphere is not dense, not warm, not forgiving. It is a shell of nitrogen with smaller amounts of methane and traces of carbon monoxide, a veil that expands and contracts with season, fed by ices turning directly into gas and returning again to the ground. It is fragile enough to seem temporary and persistent enough to transform the whole interpretation of the world. Pluto is not simply covered by frost, it participates in a cycle between surface and sky. That alone gives it a different kind of presence, because cycles imply exchange, and exchange implies that the landscape is never entirely still. The first backlit images of Pluto's limb are among the most arresting sent back by New Horizons. The sun shines from behind the world, and around its black silhouette appears a delicate, luminous blue ring. It is one of the most surprising sights in the outer solar system, not because blue is impossible there, but because it seems emotionally misplaced. Blue atmospheres belong in the imagination to living skies, to weather, to oceans implied by colour. Pluto's blue does not promise any of those things. It comes from haze particles scattering light, probably tiny complex hydrocarbons produced when solar ultraviolet radiation breaks apart methane high in the atmosphere. Those fragments react, combine, and descend through the air in a slow chemical rain. The blue ring is therefore not evidence of warmth or abundance. It is evidence of chemistry happening in the cold, a sky quietly manufacturing darker substances from simpler gases. New Horizons finds not a featureless mist but multiple layers of haze, extending far above the surface. Some layers appear crisp and distinct, stacked in the atmosphere like faint sheets. Their origin is still debated in detail, but they likely form through a combination of photochemistry and atmospheric waves, where changing temperature and pressure allow haze to condense more readily at some heights than others. Whatever the precise mechanism, the layered structure matters because it makes Pluto's atmosphere feel structured rather than incidental. This is not a random exhalation of gas hovering around a cold rock. It is an organized envelope with vertical complexity, shaped by energy, chemistry, and motion. The atmosphere may be thin, but it behaves like a true system. Methane is central to this transformation. Exposed to sunlight, even the weak sunlight at Pluto's distance, methane molecules can break apart. Once broken, their fragments can recombine into more complicated hydrocarbons and nitriles, materials that eventually grow into larger particles. Over time, these particles settle out. On Pluto, the result is believed to be tholins, a broad term for reddish organic residues produced when simple carbon-bearing molecules are processed by radiation. Tholins are not signs of life, but they are chemically rich in a way that always stirs imagination. They are the products of complexity emerging from simplicity in the absence of biology. On Pluto, they seem to stain the surface in red and brown tones, especially in older regions where fresh volatile frosts do not constantly bury them. This is why parts of Pluto look dark and ruddy rather than uniformly pale. The sky has been working on the ground for vast stretches of time. This quiet chemical snowfall changes the meaning of Pluto's colours. The great dark equatorial region known as Cthulhu Macula appears rich in ancient processed material, darker and redder than the brighter nitrogen-dominated heart. The contrast suggests a surface divided not only by topography and ice composition, but by age and exposure. Where volatile ices are renewed or transported, brightness persists. Where the surface remains stable for long enough, the atmosphere and radiation alter it, accumulating deeper tones. The red is therefore a kind of memory. It records where time has been allowed to settle. It marks landscapes that have stood still long enough to be chemically weathered by the sky. This has a particularly eerie effect in high terrain. Some mountain peaks and uplands appear dusted or capped by darker reddish material. On Earth, height often means snow, fresh brightness, reflective cold. On Pluto, the temperature structure can make some summits favourable places for methane condensation, and over time the chemistry that acts on this methane can leave behind darker coatings. The result is a reversal that seems almost designed to unsettle terrestrial intuition. The high places are not always whiter. In some regions they are redder. The sky deposits stain rather than purity. Peaks acquire a muted, blood-tinted cast under a sun too distant to warm them. This is not theatrical. It is the natural consequence of temperature, radiation, and methane behaving under outer solar system conditions. Yet the effect on the imagination is profound. It makes the world feel as though even its weather is alien in principle. Pluto's atmosphere also complicates the question of time. Before New Horizons, stellar occultation measurements had already shown that the atmosphere does not behave exactly as simple collapse models once suggested. As Pluto moved farther from the Sun after passing perihelion in the late 20th century, many expected its atmosphere to shrink dramatically as surface frosts cooled and refroze. Instead, observations indicated that atmospheric pressure had increased for a time, or at least remained more robust than anticipated. This likely reflects thermal inertia, the tendency of ices and surface layers to respond slowly to changing sunlight. Even when Pluto begins receiving less solar energy overall, some regions may continue warming or releasing gas because stored heat and the shifting distribution of volatile frosts lag behind the orbital geometry. This delay gives Pluto's climate a strange patience. Its seasons do not merely follow distance from the Sun in a simple curve. They unfold with memory, lag, and redistribution. The atmosphere persists not because the cold is weak, but because the system responds slowly enough to carry past conditions forward. That delay matters because Pluto's year lasts about 248 Earth years. A season there is not a brief phase, but an epoch. The tilt of Pluto's axis is also extreme, meaning sunlight reaches different hemispheres in dramatic, long-lasting ways. Over decades and centuries, nitrogen and methane can migrate on a planetary scale, freezing out in one region, sublimating in another, altering pressure, reflectivity, and local temperature. Pluto is therefore not merely a cold world with weather. It is a world whose climate moves so slowly that direct observation over a human lifetime catches only fragments of larger patterns. Every atmospheric snapshot may be part of a cycle that takes generations to unfold. That scale of change creates a special kind of uncertainty. The world seen by New Horizons in 2015 is real, but it may not be typical. It may be one phase of a long-breathing pattern. The heart basin may brighten and darken differently across centuries. The atmosphere may swell and thin in ways only partly captured so far. Red deposits may accumulate or be hidden again beneath migrating frost. Pluto's appearance may be seasonal to a degree that no single mission can fully contain. The haze layers deepen the sense that unseen motion is constant. Winds on Pluto are not expected to be powerful in the earthly sense, yet the atmosphere can still transport fine particles and redistribute energy. Gravity waves or topographic influences may produce the layering seen at the limb. Even weak circulation matters when the environment is so delicate. The atmosphere need not roar to be consequential. It only needs to keep connecting surface and sky. In a place once thought almost inert, That connection is already enough to revise the entire portrait. Pluto does not sit under empty vacuum. It lives beneath a changing envelope that forms, settles, stains, and perhaps helps shape the deposition of ices on the ground below. There is also a deeper speculative edge to this chemistry. Tholins and related products are often discussed because they occupy an intriguing middle ground between simple molecules and the kinds of complexity that, in other settings, can become part of prebiotic chemistry. Pluto is far too cold at the surface for familiar biological processes, and nothing about its red material suggests life. But the fact that sunlight can drive methane and nitrogen toward more elaborate organic residues in such a remote and frozen environment widens the sense of what chemistry the solar system can perform without any help from warmth or oceans at the surface. Pluto becomes not a failed planet, but a chemical workshop operating at the very edge of sunlight. Simple gases rise, are broken apart, recombined, and return to the ground as dark dust. A tiny atmosphere becomes a factory for complexity. The blue haze is especially effective at hiding how severe this reality is. It is beautiful in a way that invites a softer interpretation. The ring around Pluto in backlit images seems gentle, almost delicate enough to vanish if touched. But the beauty comes from suspended particles built through radiation, from methane stripped and rearranged, from a sky that slowly manufactures the red coating of the land. The glow is not separate from the darkness of the surface. It is its source. The atmosphere does not merely soften Pluto's outline. It writes on it. The red plains, the dark belts, the stained summits, all may carry the signature of this faint blue shell. Then there is the emotional strangeness of a blue atmosphere under a black daytime sky. On Earth, blue usually means diffuse daylight filling the whole dome overhead. On Pluto, the sun is too faint and the air too thin for that. The sky near the surface would likely remain dark, perhaps with a subtle glow toward the sun, while the haze reveals itself most clearly in the right geometry, especially when backlit. This creates one of Pluto's sharpest contradictions. It has a blue atmosphere, yet not a blue day. It has weathering from the sky, yet almost no true weather in the familiar sense. It has haze layers like a living climate system, yet the surface below lies in cold that hardens water into stone. Pluto keeps combining signs of vitality with conditions that should forbid anything lively. This is why it feels uncanny. It borrows the outward hints of dynamic worlds while refusing the assumptions those hints usually carry. By the time the atmosphere is fully considered, Pluto has become impossible to reduce to a simple frozen object. The world has a moving nitrogen basin, mountains of water ice, broad regional color differences, seasonal transport of volatiles, layered haze, and a chemistry that slowly paints the landscape red. Nothing about this requires exaggeration. The facts themselves are enough. The sky is thin but not absent. The chemistry is slow but not trivial. The climate is weak by terrestrial standards, but still strong enough to move matter from region to region and alter the face of the world across long seasons. Pluto is not only shaped by what lies beneath it, it is also shaped from above by a delicate atmosphere that should barely exist, and yet has been quietly remaking the surface for ages. And every time the haze settles, it leaves behind another reminder that even at the cold edge of the solar system, the line between surface and sky is not a boundary. It is an exchange. The deepest change in Pluto's image does not come from a mountain, a haze layer, or even the bright heart itself. It comes from the growing suspicion that the visible surface is only the roof of a larger hidden structure. Once Sputnik Planitia is mapped and measured, once its strange youth and its position on Pluto are studied carefully, the old picture of Pluto as frozen all the way down begins to break. The problem is not merely that the basin is active. The deeper problem is that the basin seems to matter too much to be explained by surface processes alone. It sits where it does in a way that suggests gravitational significance. It appears associated with a positive mass anomaly, as though something dense below it is helping hold that region in a stable orientation. This is an awkward fact for a simple frozen shell. A great impact basin should remove material. It should create a deficit, not an excess. Yet the geometry of Pluto's face, especially the way Sputnik Planitia lies roughly opposite the tidal pull of Charon, hints that the world may have reoriented itself so that this basin moved into a preferred position. For that to happen, the basin must somehow act like a weight rather than a hollow. The surface alone does not easily explain that. The answer, if there is one, may lie beneath the crust. This is where the idea of a subsurface ocean becomes more than fantasy. It does not arise from a wish to find hidden water in every cold world. It arises because Pluto's observed properties make better sense if liquid or partially liquid material still survives deep below the outer ice. If an ancient impact excavated the region that became Sputnik Planitia, it may have thinned the overlying shell enough for denser water beneath to rise closer to the surface. That uplifted mass, even if still buried beneath many kilometers of ice, could help compensate for the missing crust. In that case, the heart basin is not only a scar filled with nitrogen, it is a window, indirectly, onto Pluto's interior structure. Its existence on the surface would then record an unseen layer below, one denser than the surrounding ice shell, one that has not frozen entirely solid despite the unimaginable cold above. The possibility sounds improbable until Pluto's internal history is considered. Although small, Pluto is not made only of ice. It contains a substantial rocky component, and rock carries radioactive elements that release heat over long spans of time. The heat is weak, nothing like the intense internal power of Earth, but in a world insulated by thick ice and operating under extreme cold. Weakness is not the same as irrelevance. A little heat can matter if it is trapped well enough and spread over billions of years. Early in Pluto's history, when leftover formation heat still lingered and radioactive decay was stronger, internal temperatures may have been significantly higher. If liquid water formed at depth, then the question becomes whether it could remain there, insulated by the outer shell, protected by pressure, and perhaps mixed with compounds such as ammonia that can lower the freezing point. The outer solar system has made this question harder to dismiss with each new mission. Europa, Enceladus, Titan, and other icy bodies have shown that hidden water is not a rare imagination, but a recurring planetary solution. Pluto is more isolated and less obviously energized than those examples, yet its data do not let the possibility go. There are hints beyond the mass anomaly. Pluto's surface carries signs of extension, long fractures and troughs that suggest the crust has been pulled apart in places. One broad region, informally known as Virgil Fossé, preserves evidence that may involve past cryovolcanic activity, where subsurface material, perhaps water-rich slush, pushes upward and freezes at the surface. The interpretation is cautious, because cryovolcanism is difficult to prove from a single flyby, but the terrain is difficult to ignore. There are large mounded structures elsewhere as well, such as Wright Mons and Picard Mons, broad rises with central depressions that do not fit neatly into ordinary impact or tectonic categories. Some researchers have suggested these may be cryovolcanoes, places where watery or slushy material once extruded from below. If that reading is even partly correct, Pluto has not merely preserved a buried ocean. It has, at some time, allowed the deeper interior to communicate with the surface. That would make the shell less a sealed tomb than a porous history of upward leakage. Even without direct cryovolcanism, the tectonic record tells a story. If an internal ocean gradually freezes over time, Water turning into ice expands. That expansion can push outward on the crust, stretching it and leaving long extensional features. Pluto's surface shows many such signs of stretching rather than global compression. That is significant because a world that freezes from within can crack itself open. Instead of shrinking into a wrinkled shell, it can enlarge slightly and split. The fractures across Pluto therefore fit a picture in which some deep liquid has been changing state over long periods, not all at once, but slowly enough to deform the exterior. The surface becomes a ledger of internal transition. What looks at first like a frozen, finished body may instead be a world still adjusting to a deep reservoir that has not settled into final form. The ocean, if it exists, would not resemble anything inviting. It would lie beneath an immense shell of ice, probably tens or even more than 100 kilometers thick depending on the model, under darkness so complete that no surface light could ever reach it. Its roof would be frozen water hard as stone. Above that roof would sit layers of colder ice, nitrogen plains, red deposits, mountains, haze, and the distant weak sun. The ocean itself would be pressurized, isolated, perhaps stratified, perhaps partly slushy in places, perhaps chemically enriched by contact with rock below. This is not an open sea in the imagination of terrestrial life. It is a buried black reservoir, sealed away from the surface by a planetary lid. Yet buried water has a peculiar power over scientific imagination because it changes what a world is capable of, even when life remains entirely uncertain. Liquid allows transport, it allows chemistry, it allows heat to move differently. It allows interiors to remain active in subtle ways long after surfaces appear dead. That is why Pluto's ocean hypothesis matters even if it never advances beyond strong inference. It transforms the logic of the whole planet. Without a buried ocean, Pluto is already surprising but still interpretable as a mostly frozen body with surface and atmospheric cycles. With a buried ocean, Pluto becomes vertically complex in a much deeper way. The heart basin above may connect indirectly to liquid below. The tectonic fractures may record gradual freezing in progress. Possible cryovolcanic constructs may mark breaches in the shell. The dwarf planet once dismissed as an endpoint becomes one more example of the solar system's habit of hiding water in places where sunlight has almost no power. The temptation, once buried water is introduced, is to jump immediately toward life. The narrative itself almost forces that turn because water in darkness under rock sounds like a setting where biological possibility cannot be ruled out absolutely. But Pluto requires restraint. Nothing observed by New Horizons indicates life. No plume carries samples into space. No ocean lies close to the surface in a way that can be tested by direct chemistry. No clear source of large ongoing energy comparable to tidal heating is visible. The known facts are narrower and still extraordinary enough. Pluto may retain liquid water at depth. Its rocky core may provide some heat and perhaps chemical gradients. Its crust may have recorded that hidden water through stresses and mass distribution. That is where certainty ends. Beyond it lies only careful speculation. Even so, the speculation has structure. If Pluto's interior contains a rocky core in contact with deep water, then water-rock interactions may occur. On Earth and elsewhere, such interactions can generate chemical disequilibria, differences in composition and energy that matter for geology and, in some settings, for biology. Ammonia or salts mixed into the water could keep parts of the ocean liquid at lower temperatures. Layers of ice under pressure can behave in unexpected ways, perhaps forming barriers or channels depending on depth and composition. The ocean may not be uniform. It may have frozen from above and below at different times. It may be retreating, surviving only in pockets. It may once have been global and now be regional. It may be more stable than feared because the insulating shell is thicker than assumed. Each version carries a different Pluto hidden beneath the same surface. What the flyby provides is not a direct map, but enough contradictions at the surface to make hidden depth the simplest way to reduce them. There is something especially haunting about the location of this possibility. Pluto lies in the Kuiper belt, in a region long treated as the cold storage of the solar system, a place where leftover building blocks drift in deep freeze. Yet if Pluto carries an ocean inside, then even here, where the sun is reduced to a bright star and the surface temperature falls to extremes that turn water ice into bedrock, the old elements of planetary activity endure. Heat remains, water remains, structure remains. A buried liquid world may still be present under a face of frost and nitrogen. The farther out the solar system extends, the less reliable warmth becomes as the measure of complexity. Pluto suggests that complexity may survive in cold, provided the shell is thick, the chemistry is right, and time is long enough. The heart on Pluto's surface then acquires a final ambiguity. It is bright because of volatile ice. It is young because of resurfacing. It is shaped by a great ancient impact. It may help regulate climate, but it may also be the place where the outer shell is thinnest, where hidden water once rose closest, where the dwarf planet's buried mass reveals itself most strongly. The symbol that first seems almost playful becomes, under analysis, a marker of internal imbalance. It is not a message, it is a symptom. It points toward a deeper Pluto, one not visible in any image, one inferred from motion, gravity, and fracture. The visible world says that something below still matters, and that is the quiet terror at the center of Pluto's geology. The surface is cold enough to appear final. The distance is great enough to imply exhaustion. Yet the data keeps suggesting incompletion. Pluto may not be finished freezing. It may still be settling, cracking, compensating, and preserving a dark ocean beneath its crust. A place once imagined as the dead edge of the solar system instead begins to resemble a sealed interior world, its most important activity hidden under a shell so old and strong that only a few hints reach the surface. Nothing swims in the evidence, nothing lives in the measurements. But the idea of black water under that ice remains, and once it enters the picture, the entire planet changes. Pluto is no longer merely far away. It is closed. Pluto does not endure its strangeness alone. Beside it moves Charon, a companion so large relative to Pluto that the usual language of planet and moon begins to fail. In most familiar systems, a dominant body holds its smaller satellite in a secondary role. The center of motion lies well inside the larger world. The moon circles the planet, and the hierarchy is obvious. Pluto and Charon resist that arrangement. Charon is so massive compared with Pluto that the center around which they both revolve lies outside Pluto itself, in empty space between them. They are a binary pair, two worlds locked together in a mutual orbit, each held by the other strongly enough that neither can fully claim the center. This is not merely a numerical curiosity. It alters the psychological shape of the entire system. Pluto is not a solitary frozen outcast with an attendant moon. It is one half of a double world suspended in the Kuiper belt, each body permanently facing the other, each turning with the same slow rhythm, each presenting one fixed hemisphere to its partner forever. That tidal locking gives the pair an almost ceremonial stillness. Charon never rises and sets in Pluto's sky as Earth's moon does. From the hemisphere of Pluto that faces Charon, the giant moon hangs in essentially the same place all the time, looming over the landscape without motion, except for small shifts caused by the observer's position. From Pluto's far side, Charon is never seen at all. The same is true in reverse. Pluto hangs over one hemisphere of Charon and is absent from the other. This divides both worlds into permanent near sides and far sides, regions defined for billions of years by whether the other body is always present or eternally absent. The result is difficult to imagine because human experience is built around moving skies. On Pluto and Charon, the most important neighbouring world does not cross the heavens. It watches or it vanishes, depending entirely on where the ground stands beneath it. This stillness gives the system an eerie quality. The relationship is not dynamic in the visual sense. It is fixed, locked, unavoidable. Each world has become part of the other's horizon. The likely origin of this arrangement reaches back to violence. Most models suggest Pluto and Charon formed after a giant collision early in the history of the outer solar system. A large impact between Proto-Pluto and another substantial icy body may have blasted material into orbit, some of which later collected into Charon and the smaller moons. If so, the present calm binary system is the long-cooled residue of catastrophe. That origin matters because it makes the pair feel less accidental. Their present balance is not a gentle coincidence. It is the outcome of an event severe enough to remake the primary world, perhaps excavate deep layers, perhaps help set the conditions that later allowed structures such as Sputnik Planitia and the small moons to exist. Pluto and Charon do not merely accompany each other. They are the surviving architecture of an ancient collision. New Horizons shows at once that Charon is not a lesser copy of Pluto. It is a different kind of world, slightly more than half Pluto's diameter. Charon lacks the broad, volatile, rich heart and much of the red and bright contrast that define Pluto's face. Its surface is dominated by water ice rather than thick deposits of nitrogen and methane. It appears greyer overall, more subdued, more austere, yet it is not geologically simple. One of the most striking features on Charon is a vast system of fractures, canyons, and broken terrains stretching across large parts of the Moon. These immense chasms are among the largest known in the solar system relative to body size, suggesting that Charon's crust has been pulled apart dramatically. The most likely explanation is that Charon once held a subsurface ocean that later froze. As water turns to ice, it expands, and that expansion could have split the shell open, leaving behind the enormous tectonic scars seen today. In that sense, Charon mirrors Pluto in an unsettling way. It, too, may have once hidden an ocean under a frozen exterior. It, too, may record internal change in its fractures. The binary world may therefore be stranger on both sides. The northern pole of Charon adds one of the system's most haunting details. There, spread across the polar region, lies a dark reddish stain called Mordor macula. The name is memorable, but the science behind it is even more compelling. The leading explanation is that methane escaping from Pluto's atmosphere drifts through space and is captured by Charon, especially at the cold pole where winter darkness allows it to freeze and remain. Over time, sunlight and radiation process this trapped methane into heavier organic material, darkening the region into a red cap. If that interpretation is correct, then Pluto and Charon do not merely orbit together. They exchange substance. Pluto loses gas, and Charon preserves the residue. The red polar stain becomes a chemical signature of their intimacy. One world is literally writing on the surface of the other. This exchange has profound significance for the character of the system. It means Pluto's atmosphere is not wholly Pluto's. Some portion of its escaping gas does not vanish into space, but becomes part of Charon's visible history. The pair are linked not only by gravity and orientation, but by material transfer. Charon, colder in some respects and less able to sustain its own volatile atmosphere in the same way, becomes a trap for what Pluto sheds. That makes the binary system feel almost circulatory. as though even their separation has not fully broken the shared story of their origin. Pluto breathes outward, and Charon remembers. The red pole is not simply decoration. It is evidence that the gap between the worlds is chemically active over immense time. The contrast between their surfaces makes this shared history even more striking. Pluto is crowded with volatile cycles, nitrogen glaciers, hazes, red and pale contrasts, and signs of continuing climatic exchange. Charon looks more stripped, more skeletal, more openly dominated by water ice and tectonic fracture. If Pluto is the breathing, restless half of the system, Charon is the colder archive. Yet that difference does not make Charon inert. Its great canyons imply internal change. Its smoother southern plains may record resurfacing events, perhaps cryovolcanic flows or eruptions of ammonia-rich water slush in the past. Though the details remain uncertain, Charon is quieter than Pluto in some respects, but it is not geologically empty. It carries its own evidence that hidden warmth once mattered, and perhaps mattered long enough to restructure its crust. Thus the pair do not divide into active and dead so neatly. They divide into different expressions of cold planetary history. Their tidal locking also stabilizes the system in a way that shapes every other component, because Pluto and Charon rotate synchronously, because they hold each other so steadily. The smaller moons orbit within a more complex gravitational environment. Nix, Hydra, Kerberos, and Styx move farther out, influenced by the combined mass of the central pair. These small moons are irregular in shape and behave chaotically in rotation, tumbling rather than turning with tidy calm. Their orbital arrangement and spin states reflect the unusual gravitational architecture created by the binary. In other words, Pluto and Charon do not simply coexist. Together they create the dynamical field that governs the rest of the system. The center is not singular. It is shared. Everything else orbits that fact. Seen together, Pluto and Charon also make the old demotion feel strangely inadequate. The category dwarf planet says something taxonomic about Pluto's place in the solar system, but it says almost nothing about the lived complexity of the system itself. A binary world with exchanged atmosphere, possible hidden oceans on both bodies, permanent mutual orientation. And multiple smaller moons is not a diminished version of a planet. It is a distinct class of place, one that the classical planetary list never prepared the imagination to understand. Pluto loses status in the old scheme and gains depth in the new one. Charon is part of that transformation. Without Charon, Pluto might still appear exotic but solitary. With Charon, it becomes relational. Its mystery extends into the space between worlds. That space is cold, sparse, and mostly empty. Yet even there the system seems more connected than distance suggests. Methane moves across it. Tidal history has shaped both bodies. The orientation of Pluto itself may be related in part to the gravitational logic of the basin facing Charon. The pair have settled into their current faces and kept them for so long that surface climates and volatile distributions must have adapted to this permanent arrangement. On Pluto, the hemisphere directed toward Charon carries the heart basin. Whether by coincidence, history, or deep interior compensation, the most iconic feature of Pluto's surface faces the partner that never leaves its sky. This is not proof of intention, only one more alignment in a system already crowded with them. Yet such alignments contribute to the unease. Pluto and Charon seem less like separate accidents, and more like halves of an old solution whose full history remains hidden. The image of Charon hanging motionless above Pluto's horizon captures that unease better than any measurement. A fixed moon is not a moon in the ordinary sense. It is a permanent presence, an object that becomes part of the landscape itself, over the bright plains, Beyond the water ice mountains, under the dark sky and the thin blue haze, Charon remains. It does not cross, it does not drift away. It simply occupies its place, immense and unwavering, while Pluto turns beneath the sun in slow seasons lasting generations. The smaller moons tumble farther out. Red dust settles. Nitrogen migrates. Hidden water may remain below the crust. And through all of it, Pluto and Charon continue their locked rotation around an invisible point between them, each world carrying scars of old heat and old collision, each preserving some part of the other. This is not a planet and its moon in the familiar story of the solar system. It is a divided world, frozen into mutual attention, sharing shadow, gravity, and a chemistry that crosses the dark. Beyond Pluto and Charon, farther out in the weak gravitational field of the binary pair, the system becomes smaller in size but no less strange. Nix, Hydra, Kerberos, and Styx are tiny compared with the central worlds, irregular bodies discovered only in the years before the New Horizons encounter. At first they seem like expected debris, minor leftovers from the system's formation, too small to command much attention beside the pale heart of Pluto and the fractured face of Charon. Yet when their motions, shapes, and surfaces are examined, they begin to look less like simple satellites and more like clues that the whole Pluto system was assembled through violence and has never entirely relaxed from it. The central pair already suggests an ancient giant impact. The smaller moons preserve the scattered edge of that event, the shattered fringe that still moves under rules unlike those of more orderly satellite families. New Horizons reveals that some of these moons are brighter than many had expected, especially Nix and Hydra. Their surfaces reflect a surprisingly high amount of sunlight, implying abundant water ice, perhaps relatively clean compared with darker, more heavily processed objects elsewhere in the outer solar system. This brightness alone is not the strangest part. More unusual is the way these small moons rotate. Instead of turning with stable, regular synchronization like Pluto and Charon, they tumble in chaotic states. Their spin axes wander. Their rotation periods do not settle into simple, tidy relationships with their orbits. In most planetary systems, tidal forces over long spans tend to calm such motions, especially for small bodies close to a dominant primary. But the Pluto system is not centered on a single dominant body. It is centered on a binary. The combined and changing gravitational pull of Pluto and Charon creates a more complicated environment, and the tiny outer moons respond with instability in rotation. They orbit predictably enough, but they do not present fixed faces in orderly fashion. They tumble through the dark like fragments that have never fully forgotten being fragments. That image matters because it sharpens the sense that the system is a preserved aftermath. Pluto and Charon are the largest survivors of a formative collision, smoothed by time into a stable binary dance. The outer moons are the smaller remnants, trapped but not fully pacified. Their irregular shapes, their brightness, and their chaotic spins together suggest material blasted outward and later gathered into modest bodies under conditions unlike those that form the classic regular moons of the giant planets. They are not merely decorations orbiting a distant dwarf planet. They are structural evidence that the whole architecture of the system is secondary, born after disruption. The frozen kingdom around Pluto is not ancient in the sense of untouched continuity. It is ancient in the sense of long survival after destruction. The resonant structure of the system adds another layer. The small moons occupy orbits that fall close to simple integer relationships with Charon's orbital period, though the exact dynamics are subtle and not perfectly idealized. This near patterning suggests long-term gravitational shaping after formation. The moons are not randomly scattered. They have settled into preferred regions, perhaps nudged there over time by the evolving binary and by each other's interactions. Once again, Pluto resists the idea of being merely accidental debris at the edge of the solar system. Even its smallest companions show that order can emerge from shattered beginnings, though in this case the order never becomes entirely serene. The moons circle in a configuration that is stable enough to endure but strange enough to remind observers that the centre they orbit is not a planet in the classical sense, but a pair, because the system is so compact in one respect and yet so open in another. Every small moon feels like a boundary marker. Inside, Pluto and Charon dominate with their fixed faces, exchanged materials, and possible hidden oceans. Outside, the tiny satellites mark the outer reach of that influence. Bodies too small to hold atmospheres, too small to sustain large-scale geology of the sort seen on Pluto, yet large enough to preserve the ice-rich signature of their origin. They are the last visible consequences of the impact that may have produced the binary. In a system otherwise defined by slowness, they provide one of the clearest reminders that the present calm is not the original state. Something violent happened here. The evidence still orbits. If the giant impact scenario is correct, then the system's story begins not with a neat frozen object moving undisturbed through the Kuiper belt, but with collision, excavation, and reassembly. A large proto-Pluto collides with another body in the early solar system. Material is blasted into orbit. Some remains around the primary, eventually combining into Charon, perhaps with enough mass to become nearly a peer rather than a minor moon. Smaller fragments persist farther out and form the tiny satellites. The central bodies evolve tidally until they lock to one another. Interiors heat, cool, and perhaps form oceans. Surfaces freeze, crack, darken, brighten, and exchange gas. The result is not an original world, but a reconstructed one. Pluto's present dignity is post-catastrophic. Its stillness has been earned after ruin. This matters because it reframes many of the system's most striking features. Sputnik Planitia may itself be a later impact basin superimposed on a world already shaped by an earlier giant collision. Charon's great fractures may reflect the delayed consequences of an interior transformed during or after formation. The smaller moons preserve ice-rich debris from the same ancestral violence. Even the current orientation of Pluto and the placement of the heart facing Charon may be, in part, downstream consequences of a history that begins in collision and then branches into tidal evolution, internal heating, climate cycles, and resurfacing. Nothing in the Pluto system seems purely original anymore. Everything is layered. Every calm surface implies an older break beneath it. The small moons also widen the scale of imagination in another way. For many years, Pluto was treated as the final named body, the last marker before emptiness. But as the Kuiper belt came into view through modern surveys, Pluto began to look less like a lonely exception and more like the largest known representative of a vast outer population. The presence of multiple moons reinforces this shift. Pluto is not merely one object among many. It is one of the few Kuiper belt worlds close enough to reveal itself as a system. The small moons are a reminder that beyond Neptune there may be many histories equally complex, many collision families, many hidden internal structures on bodies never visited. Pluto becomes the visible sample of a broader class, a hint that the outer solar system contains more architecture than the inner planetary list once suggested. The tiny moons are not just part of Pluto's local story. They are ambassadors from an unseen census of distant icy systems. Their chaotic tumbling has a symbolic force because it stands against the absolute locking of Pluto and Charon. At the centre, two large bodies face each other forever. Beyond them, four tiny moons spin unpredictably. Order and instability coexist within the same miniature kingdom. The binary pair behave with near ceremonial regularity. The smaller fragments refuse elegance. This contrast gives the system a textured emotional reality. It is not uniformly calm or uniformly broken. It is both. The central wound has healed into symmetry. The outer debris still carries a symmetry and motion. Such a combination feels more believable than a perfectly tidy system would. Nature often leaves signs of its past in whatever remains the least settled. In Pluto's case, the smallest moons are those signs. There is another subtle consequence of their existence. Any spacecraft flying through the system must account not only for the positions of the moons themselves, but also for the possibility of dust and unseen debris associated with them. During the approach of New Horizons, the mission team takes this possibility seriously. At the flyby speed involved, even tiny particles could be dangerous. That concern gives the moons a practical menace beyond their size. They are small enough to be hard to study in detail before arrival, and potentially dangerous enough to threaten the encounter. Pluto's kingdom is not just mysterious. It is cluttered with the leftovers of processes not fully constrained from afar. The spacecraft survives, and no destructive debris field appears, but the concern lingers as part of the psychological atmosphere of the encounter. Even the small moons carry uncertainty. Their names themselves, drawn from underworld and Night River mythology, fit almost too well. Styx, Nyx, Kerberos, Hydra. In another context, such naming might feel decorative. Here it feels descriptive. The system is not sinister in any supernatural sense, but it does evoke a borderland quality, a place beyond the warm order of the inner planets where categories and intuitions fray. Pluto and Charon stand as a double world with fixed mutual faces. A bright heart covers a moving basin that may point to hidden water below. Mountains of water ice edge a sea of nitrogen. A blue atmosphere slowly paints the land red. Tiny moons born of a colossal impact tumble chaotically under the gravity of two masters. Every layer of the system carries the same message in different form. What seems at first peripheral becomes central. What seems small becomes structurally important. What seems finished turns out to be the visible remnant of deeper events. By the time the outer moons are placed back into the full story, Pluto's old image as a discarded minor body has become difficult to even remember. The category remains, the taxonomy remains, but the meaning of the place has changed beyond repair. Pluto is not merely one sphere, it is a system, and systems tell stories that single objects often hide. The small moons whisper the first chapter, the chapter of impact, ejection, and aggregation. Pluto and Charon tell the middle chapters of tidal locking, internal change, and atmospheric exchange. Sputnik Planitia tells a later chapter of resurfacing, mass anomaly, and perhaps subsurface ocean. The whole structure reads like a compressed planetary epic written in ice, rock, and time. The smallest bodies only seem minor because their scale is small. Their role in the mystery is not small at all. They are the last moving pieces of the ancient blow that may have made the kingdom possible, and in their chaotic turning they preserve a truth the larger worlds can almost conceal. This frozen realm was born broken. By the time all of Pluto's pieces are held together at once, the most unsettling fact is no longer any single feature. It is the pattern formed by their coexistence. On one world at the edge of the solar system, there is a bright basin of nitrogen ice so young that it appears to be renewing itself in the present era. Around it rise mountains made of water ice hard enough to behave as stone. Above it hangs a layered atmosphere that should be too fragile to matter, and yet is active enough to stain the land red over time. Beneath it may lie a buried ocean, preserved against total freezing by weak heat, pressure, and the patient insulation of ice. Beside it moves a giant moon locked forever in place. bearing a red polar stain likely made from Pluto's own escaped atmosphere. Around both of them tumble smaller moons that preserve the debris of an ancient collision. None of these facts alone breaks planetary logic. Together they transform it. Pluto ceases to be the discarded fringe of the old solar system and becomes something more difficult to classify in ordinary language, a cold system of interacting layers whose surface beauty keeps pointing toward hidden structure. This is what makes Pluto terrifying in a quiet way. It does not terrify through violence on the scale of Jupiter's storms, or the infernal heat of Venus, or the tidal torment of Io. It terrifies through contradiction sustained with perfect calm. Everything about it ought to suggest final stillness. The sunlight is weak. The temperatures are severe enough to harden water into bedrock. The world is small, distant, and old. Yet the data insist on activity. Not loud activity, not catastrophic activity unfolding in plain sight. The more unsettling kind. Slow circulation in a nitrogen plane, seasonal breathing of an atmosphere, chemical snowfall from a blue haze, crustal stretching that hints at internal change, a possible ocean sealed under a shell so cold and thick that almost nothing of it should remain. Pluto behaves like a place that has no right to remain this dynamic, and yet it does. There is a reason this changes more than one dwarf planet's reputation. Pluto forces a revision in how remoteness is understood. For a long time, distance from the Sun was mentally associated with simplification. The farther out a world lies, the less energy it receives, the less likely it is to retain atmosphere, climate, or geology, the more likely it is to become a preserved remnant. Pluto shows that this expectation is not entirely wrong, but it is incomplete. Reduced sunlight does not erase complexity. It changes the form complexity takes. In the outer solar system, energy can be stored, delayed, and redistributed over timescales so long that quiet worlds remain active long after intuition expects them to freeze shut. Materials behave differently. Nitrogen becomes terrain. Water becomes crust. Methane becomes weather and then residue. A world that looks still from a distance may be alive with processes too slow and too alien to resemble the activity of warmer planets. This gives the Kuiper belt a different emotional weight. Before Pluto was seen up close, that region could be imagined as a sparse graveyard of frozen leftovers, a cold archive of formation material. It is still an archive, but Pluto suggests that archived does not mean inert. Bodies out there may carry histories not only of origin but of prolonged internal and surface evolution. Pluto is likely not unique in having layers, cycles, and aftermaths. It is only the first of its kind to have been seen well enough for those layers to become undeniable. If one object in the Kuiper belt can carry a nitrogen basin, a probable buried ocean, a binary companion system, climate cycles, and organic surface chemistry, then the unseen majority may also hide structures too strange to predict from Earth-based assumptions. Pluto becomes less an exception, and more a warning that the outer solar system is conceptually unfinished. The mission that revealed all this is itself part of the mystery's shape. New Horizons does not orbit Pluto. It does not linger to watch a season change or return years later to test a hypothesis. It races past once. The knowledge it provides is astonishing, but it is also fragmentary by the standards required to understand a changing world. The hemisphere seen in greatest detail is only one side. The atmosphere is sampled during one moment in a very long climatic cycle. The hints of a subsurface ocean come through indirect reasoning from surface orientation and tectonic patterns, not from direct sounding of the interior. The possible cryovolcanic structures remain interpretations, not settled verdicts. Even Sputnik Planitia, for all the evidence of convection and resurfacing, is known through still images rather than repeated monitoring. Pluto therefore remains partly withheld. It has already overturned the old assumptions, Yet it has done so while keeping its central processes mostly out of reach. The world is no longer misjudged because it is unseen. It is misjudged whenever it is treated as solved. That may be the strongest reason the mystery endures. Every answer New Horizons provides opens a larger uncertainty behind it. The heart is a nitrogen basin. Why is it where it is, and how deep does its influence extend? The surface is young. How much motion continues there now? The atmosphere is layered. How does it behave across centuries of Pluto's season? The crust is fractured. Did a subsurface ocean once fill the interior, and does some of it remain liquid now? Charon is locked in mutual orbit. How exactly did the collision unfold that created the pair and the smaller moons? The red chemistry is understood in broad strokes. How does it vary from region to region over time? And what does it reveal about Pluto's environmental history? Pluto gives enough evidence to dismiss the simple story and not enough to replace it with final certainty. It stands in a rare position, both known and deeply unfinished. Even the language used for Pluto remains under strain. Dwarf planet is scientifically precise in one sense, but the phrase can still encourage the old emotional mistake, the sense that Pluto is a lesser version of something better understood. Yet the discoveries suggest the opposite. Pluto is not less because it is small, it is concentrated. Many of the solar system's most disorienting lessons converge there. Material hierarchy is inverted. Climatic exchange persists under near darkness. A giant impact may have created a binary kingdom. A buried ocean may survive beneath the crust. Surface youth appears where age should dominate. The place resists familiar categories not because it is underdeveloped, but because it occupies a set of conditions rarely encountered together. Pluto is not the reduced form of a classical planet. It is a different answer to the question of what a world can be. This is where speculation becomes hardest to avoid. Once a buried ocean enters the story, once slow internal heat and chemical gradients are admitted, once rock and water are imagined in contact under an insulating shell, the mind turns inevitably toward the possibility of things not yet measured, not organisms in any cinematic sense, not certainty, only the recognition that worlds with water beneath ice have altered scientific expectations elsewhere, and Pluto may belong, however cautiously, in that larger conversation. Still, the strongest mystery does not require life at all. Pluto is already extraordinary without it, a sealed ocean in darkness, preserved at the edge of sunlight, under a heart-shaped basin of mobile nitrogen, is enough. A world that continues to restructure itself in cold, where intuition expects geological death, is enough. The unknown here does not need inhabitants to be disturbing. The unknown is the persistence of structure itself. There is also the problem of timescale. Human attention is brief. Missions are brief. Pluto is not. Its seasons unfold over spans longer than ordinary careers. Its surface changes may require repeated observation across generations. Its deeper interior may evolve over hundreds of millions of years. The world is therefore misaligned with the habits of discovery. It can be seen once and still remain ungrasped, because the relevant rhythms are too slow for a single encounter. This introduces a final kind of unease. Pluto may be active in ways that no living observer will ever fully watch from beginning to end. It may breathe on a schedule too extended for intuition to track. It may freeze and thaw internally across ages rather than eras of science. It is not only far in space, it is far in tempo. That may be why the old act of throwing Pluto aside feels stranger now than it did in 2006. The reclassification itself stands on solid scientific logic. Pluto truly does belong to a broader population of Kuiper Belt worlds. It did not clear its neighbourhood. In that taxonomic sense, nothing discovered later reverses the vote. But emotionally and intellectually, The act now looks like the closing of a file at the exact moment the real content was about to emerge. Pluto was not diminished by what it lacked. It was misunderstood because no one yet knew what it contained. The farther the data reached, the less like debris it looked. The exiled object became a place with weather, geology, chemistry, history, companions, and perhaps deep black water below. The title planet turns out to matter less than the fact that Pluto is one of the most quietly complex worlds ever seen. And still, after all of that, it remains mostly silent. The heart does not explain itself. The mountains do not move fast enough to betray their drift. The haze settles too slowly to be watched by naked eyes. The buried ocean, if it exists, remains sealed under ice and time. Charon hangs in place. The small moons tumble. The whole system continues its long circuit under a distant sun, unchanged in essence by whatever names Earth assigns it. The final impression is not of a mystery nearing closure, but of a frontier that has only just become legible. Pluto has already given enough to overturn an era of assumptions, and yet almost every important process there still disappears into slow time, deep ice, or the darkness between worlds. What remains is not a conclusion. It is a planet-sized question, still turning at the edge of the solar system, its brightest feature pointing downward into what cannot yet be seen.